students. Today we will discuss about the concept of grouping of phases into passes in compiler. Okay, so in previous class we have discussed about different phases of compilers. There are six phases, that is lexical analysis, okay, syntax analysis, semantic analysis, intermediate code generation, code optimization. Okay, so then after that finally code generation. So those are all the different six phases. Okay, so here how we will convert that phases into passes. Okay, how we will merge those phases into passes. Those things we will discuss in today's class. Okay, this is the outline of this today's class. So first we will discuss about a grouping of phases into passes. So in that we will have one pass assembler, what do you mean by two pass assembler, three pass assembler, multi-pass assembler. Okay, so these are the different types of compilers. Okay, so based on grouping of phases into passes. Then after that we will discuss about different compiler construction tools. After that we will discuss about the evaluation of a programming languages, and next last one is the applications of compiler technology. So this is the outline of this today's class. So first thing is we will discuss about grouping of phases into passes. Okay, so we already know that a compiler is a very complex program, okay, to understand and design. Okay, so it's very complex and it will be very difficult to understand how the compiler is designed. So for that what they have done is they have divided that compiler. Okay, logically they have divided into various subprograms. Okay, so we'll call it as a modules, because a compiler is more complex program. So that's why what they have done, they have logically divide that various sub programs, okay, so into a various sub programs. So from when you convert from higher level language to lower level language, okay, so in intermediate we will have lot of things to convert. Okay, so to identify, convert, we need to identify syntax. So then after that semantic, then after that intermediate code generation, after that code optimization, finally code generation. Okay, lot of it is a very complex compiler. Okay, so that is it contains a complex program. So for that what they have done, they divide that logically into a small programs. Those small programs we will call it as a modules. These sub programs or modules we will call it as a phases. So those phases, that is there are six phases we have in the compiler. So that is, phase is nothing but a module of the compiler that accepts one representation of the program as the input and produces the another representation of the program as the output. Okay, so in syntax analysis, okay, so in first what in lexical analysis, what so it will identify the, so it will take the source program and it will identify the identifier. That is, the input is the source program, output is the identifier. So then after that in semantic analysis, it will take the source programs, then it will identify the data types. Like that, each phase having a particular function. So it will take one representation of the program and it will produce the another representation of the program as the output. Okay, so here we have a different phases: lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation, last one. Okay, so this is the we'll call it as a phases of compilers. Okay, so phases is nothing but it is a small modules or a program, sub programs. Okay, so those things we'll call it as a phases. Each phases having a specific function. Okay, so then after that, what do you mean by pass? We have discussed one pass assembler, two pass assembler. Okay, so that is a grouping of the phases, a group of one or more phases of a compiler that perform the analysis or a synthesis of the program is called the pass of the compiler. When you group the by two or more phases, okay, so when you group the two or more phases of a compiler, that one we will call it as a pass. So it may be do synthesis or it may be do analysis. Okay, so those things we will call it as a pass. When you group the two or more, one or more phases, those things we will call it as a, okay, passes. Okay, so it may, if you group a say that is analysis space. In analysis space what you are doing, that is lexical analysis, syntax analysis, semantic analysis. Those things is one, and intermediate code generation, code optimization, and another one is finally code generation. So those that is analysis and synthesis, we have made a two pass. So even though the compiler is divided into various phases, in the actual implementation of the compiler, one or more phases may be grouped together into a pass. Okay, So here, even though we have divided the compiler into n number of phases, but when we come to actual implementation of the compiler, a one or more phases may be grouped together into a pass. Okay, so one or more phases may be grouped together into a pass. Okay, so it may be a analysis phase or it may be synthesis phase. Based on this pass, we will classify it into a compiler as one pass compiler, two pass compiler, three pass compiler, and multi-pass compiler. Okay, so these are the four different types of compilers we have based on passes: one pass, two pass compiler, three pass compiler, and multi-pass compiler. Here we have four passes. So then what do you mean by one pass or a single pass assembler? Sorry, simple pass, sorry, not assembler, it will be compiler. Okay, if the analysis and synthesis of a source program is done in one flow from the beginning to the end of the program, then that compiler is called one pass compiler. Okay, so here from you know that in all six phases will be make it as a single group. Okay, single pass, all six phases will be grouped into one from the beginning till the end of the program. Okay, so here see here lexic analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generator. Okay, so these all six phases we will make it as a one pass. Okay, when you six group all the six phases into one pass, and here we are giving a source program and we will get a object program. That one we will call it as a simple single pass compiler. Okay, so that one we will call it as a single pass compiler. Okay, all six phases are grouped into a one pass, that is single pass. Then when you come to two pass compiler, okay, so here we are grouping a phases into two groups. Okay, so that is if the analysis of a source program is done is one pass and synthesis of a program is done in another pass, then that compiler is called a two pass compiler. Okay, if the analysis of the source program is done in one pass and synthesis of a program is done in another pass, then the compiler is called the two pass compiler. What is synthesis analysis part? So that is lexic analysis, syntax analysis, semantic analysis. That is we can make it as a one pass, and after that that code generation part will make it as a another phase. Okay, that is synthesis phase. That one will call it as a pass. So that is intermediate code generation, code optimizer, and code generator. So okay, so here after pass one we will get an intermediate file. That intermediate file will be the input to the pass two. So the output of that pass two will be a object program. Okay, so that is lexic analysis, syntax analysis, and semantic analysis. The three phases will be grouped into a pass one, and intermediate code generation, code optimizer, and code generator will be a pass two. Okay, so these two are the pass one and pass two. Okay, this is the two pass compiler. Okay, so then when you come to three pass, okay, so here that is we are making a three groups. That six phases will make it as a three groups. That one we will call it as a three pass compiler. How? If the analysis and synthesis of a source program is done in three different passes, then that compiler will be called as a three pass compiler. So here what we are doing, so we are making a lexic analysis, syntax, and semantic analysis, and intermediate code generation will be done in first pass, then code optimization will be done in second pass, and third one will be in code generator will be a third pass. So like that we are making a three passes. Okay, so lexic analysis, syntax analysis, semantic analysis, and intermediate code generation will be one part, and code optimizer will be another pass, and code generator will be a third pass. So this is the a three pass compiler. Okay, so if the analysis and synthesis of a source program is done in three different passes, then that compiler is called a three pass compiler. Okay, so then that pass we'll call it as a three pass compiler. Okay, so one pass is done, two pass is done, three pass is. Then last one is multi-pass assembler. Okay, so a multi-pass assembler means a multi-pass compiler is nothing but it is a multi-pass compiler is a type of compiler that processes the source code in two or more times. Okay, so here a multi-pass is more than one. It may be 4, 5, 6. If it is two, that will be considered two pass. If it is three, 3-pass assembler. If it is 4, okay, so multi-pass assembler will, so okay. So here, so in on the six, suppose if it is more than 4, so then we will call it as a multipass assembler. That is a multipass compiler. Multipass compiler is a type of compiler that process the source code 2 or more times. Okay, the difference between the multipass compilers are slower but much more efficient when compiling. Okay, so much more efficient while compiling. So here whatever the 6 phases we have, we'll make it as all individual phases as a passes, then that one will be a multipass assembler, sorry, multipass compiler. Show the output of each phase of the compiler for the assignment statement. So here we are taking a sum is equal to initial plus value into 10. So how this compiler, this statement will be converted into lower level language, assembly level language. So from all 6 phases. Okay. So first one is, what is the first phase? Lexic analysis, syntax analysis. Second one, semantic analysis. Then intermediate code generator, then code optimizer and code generator. So here's a symbol table and okay. So here we have. So here sum is equal to initial plus value into 10. So what it will do in first phase, it will identifies the identifier. Okay, so it will, in lexic analyzer, it will identifies the identifier. So here these are the variables we are assigning as a identifier. So this is, so this is the arithmetic expression as the input to the lexic analyzer, and this one will be the output. So what is the output? Sum. So the sum is the ID1. We are giving a name as ID1, comma, this is ID, comma 1. Okay. So then after that, this is an assignment operator. Okay, and after that, initial is ID. That is also ID, and number is 2. And after that, we will have a plus symbol. Okay, we'll have a plus. Then after that, value, that is a variable, so that is identifier, and it will be 3, and it will be multiplication, and after that it will be constant 10. Okay, so that one will be the output of the lexic analyzer. When you say syntax analyzer, it will identify the syntax. Okay, if any errors is there, so it will display error. So otherwise it will it will construct a tree. Okay, so here it will construct a tree based on this output of the lexic analyzer. So here what we are identifier 1. Okay, so this is the root. Okay, left side identifier 1. After that, what we have, identifier 2. Okay, so here identifier 2. So here what we have for identifier 2 plus identifier 3, and it will be, see here from all this, the root will be the a operators. Okay, so we'll discuss how we will construct a decision, this tree, parser tree, what we are calling. Okay, we'll discuss that one. Okay, so just here you will remember how it will, how tree will be represented using that identifiers. So here root of root will be equal left side identifier 1, and after that we will have a plus. Okay, so identifier 2, then star will be root, and ID left subtree is identifier 3, and it will be 10, right side 10. So here that is 10 into identifier 3. Okay, so then what is the result of that will be plus with identifier 2. Okay, so that will be, that is the result of these two things, identifier 3 and 10. The result will be added with identifier 2. That one will be assigned to identifier 1. Okay, so this is the tree, parser tree of output of the syntax tree. Okay, syntax analyzer. In semantic analyzer, what we are doing, we are identifying the variable data types. Okay, and type conversion. Okay, so here identifier 1, same thing in tree. So in that we are identifying the variable. I know we are type conversion here. So here what we are doing, the 10 will be into float. We are type converting from into float, the 10. So these things, identifier 1 is some initial value. These are all floating point. So then this 10 will be converted from integer to floating point. Type conversion we are doing. So this is the semantic analyzer. Okay, so it will identify the meaning. Okay, so and type conversion. That is the semantic analysis. Then after that, next it is the intermediate code generator. Okay, so here intermediate code generator, this here we are generating an intermediate code. Okay, so based on that tree. Okay, So here what a t1, that one will be constant, that is we are converted that one integer to float, that one will become the t1. T1 is nothing but a 10. Okay, token we are calling as a t. T is nothing but a token. Okay, so then that one will be token will be multiplied with id3. id3 is nothing but a value. Okay, so value into 10, that one will be the t2. Okay, so then that one will be the result of that identifier 3 and t1. Okay, multiplication of these two, that is the result t2 will be added with identifier 2. Okay, so will be added with identifier, that is identifier 2 plus t2. Okay, so then the result of these two things will be the t3. So then the id1 is the value is equal to value of t3. Okay, t3 is nothing but identifier 2 plus t2. T2 is nothing but a identifier 3 into t1. T1 is nothing but a into float of 10. See here, this is the whole the arithmetic expression will becomes identifier 1 is equal to t3. So like that we are, so how we are met, this is one. 10 is the t1, then identifier 3 into 10 will be the t2, then t2 will be added with identifier 2, that one will become the t3. T3 is equal to, that is identifier 1 is equal to t3. So like that we will code will be, intermediate code will be generated. Then after that we will have, this will be the output to the code optimizer. So here, so how we will optimize this? Okay, so that is identifier 3 into 10. Okay, this is the identifier 3 into t1 is 10. Okay, so that one will becomes the t1. Okay, so instead of here t1 is equal to into float, so we are optimizing the code, so it is, there is no use t1. Okay, so instead of that what we are doing, so we are identifying here 4 lines are there, so in that we need to optimize the code. How we will optimize the code? There is no use of t1 is equal to into float of 10. So instead of that, if you take a 10 floating point number, that's enough. So that is 10 into identifier 3, so that is 10 into value. Okay, identifier 3, that one will becomes the t1. T1 plus identifier t2 is equal to identifier 1. Okay, so that is the here 4 lines are there, that one will be optimized to 2 lines. Okay, so then this is the, sorry, this one will be the output of that code optimizer, will be the input to the code generator. So here we will write the assembly level language code to this. So here the constant will be immediate address. Using immediate address, we are loading to accumulator, that one will be multiplied with id3. Okay, so that one will be added with id2, and we are storing that one into id1 memory location. So like that whole thing will be generated, converted into assembly level language in different phases. So this is the example of how that arithmetic expression will be converted into assembly level language using using different phases of the compiler. Okay, this is an example. Okay, so here we will directly write this program, but how that compiler will convert those things, assembly level language, high level language into assembly level language, this is the thing. Okay, in simple table we will have a variable sum, initial and value. Okay, so this is the generation of assembly level language from high level language. Okay, so next topic is compiler construction tools. Okay, so here whenever we want to design a, we will have, that compiler designer, he may have n number of tools to design. Okay, it's very difficult to write a program for all those things. So for writing a program also we will have a different tools. Okay, the compiler writer, like any software developer, can profitably use modern software environment containing tools such as editor, debugger, and so on. So like a software developer, like compiler designer or a developer is also can use a modern software environment to develop a compiler. So here some of the tools that helps the program to build compiler very easily and efficiently are listed below. So these are the different tools they have used to develop a compiler. One is parser generator. Okay, so parser generator, what it will do, this tool, this accepts the grammatical description of a programming language and produce the syntax analyzer. Okay, so it will accept the grammatical, suppose you are declaring a grammatical mistakes, suppose you are missing a semicolon, whatever the things. Okay, or you are missing a one parenthesis, those grammatical, to identify the grammatical mistakes, So this parser generator will be used. Okay, so they accept the grammatical description of a programming language and produce the syntax analyzer. Okay, that is the first one. Then scanner generator. So what they will do, they accept the regular expression description of tokens of a language and produce the lexical analyzer. So for each phase they will have a different tools. Okay, so here for for lexical analyzer. Okay, so they are using the scanner generator. So what they will do, they will accept the regular expressions descriptions of tokens of a language and produce the lexical analyzer. We'll discuss this one, what is regular expression. I think in Lex and Yak madam already explained the regular expression. Okay, anyhow in theory class we'll discuss that one. Okay, so that regular expression of the tokens of a language and produce, it will produce the lexical analyzer. Okay, so then syntax directed translation engine, this is another tool. They produce various routines for walking a parse tree and generating the intermediate code. That is, we have discussed now that this is the parse, these are the parse tree. Okay, to generate this parse tree we will have this syntax directed translation engines. Okay, they produce the routines for walking a parse tree and generating their intermediate code. Okay, that is intermediate code. T1 is equal to T1 is equal to int float of 10. Okay, so then T2 is equal to ID3 into ID1. So that is like that. Intermediate code will be generated. For that we will have a syntax directed translated engine. Okay, so like that, then code generator generators. Okay, so use to generate a codes. For that we'll have a tool code generator code generators. Okay, so using the intermediate code generated, they produce the target language. The target language may be object program or assembly. You will have a after code optimizer, you will get a code. That code will be intermediate code will be code output of the code optimizer will be converted into assembly level language. That is, so here, you have got a code optimizer output. This one you need to convert to assembly level language. To convert this one for that code generators, if you give this one is the input. Okay, so if you give these things output of the code optimizer, if you give the input to uh, the tool, so automatically it will develop a assembly level language. Okay, so that one for that we will use the code generators. Okay, the target program may be, okay, it may be object program or it may be assembly level language program. So for that we will have a code generator code. And data flow analysis engine. Okay, so data flow analysis engine, this is also one tool that is used to gather the information of how values are transmitted from one part of the program to another part of the program, and that data flow analysis analysis is key part of the code optimization. How that from the first phase to till the last phase, how data is flowing, that is very very important. If you miss at the middle, if you miss one data, so the output will be different. Okay, so it gathers the information of how values are transmitted from one part of a program to another part of the program. That data flow analysis is a key part of the code optimization. Okay, therefore that is for that we will have this tool. And next, last one is compiler construction toolkits. Okay, so these compiler construction toolkits, they provide a set of routines for constructing various phases of a compiler. They will, these are all the additional tools they provide. Each tool having a specific function. Okay, so like compiler construction tool, it provides a set of routines for constructing various phases of a compiler. Okay, for like say various phases, that is we have a 6 phases now. So to all 6 phases, to construct 6 phases or 7 phases, at that time this construction compiler construction toolkits will provide. Okay, so these are the different 6 construction tools: parser generator, scanner generator, syntax directed translation engine, code generator, generators, data flow analysis engine, and last one is compiler construction toolkits. These are the 6 toolkits what we have in the compiler construction tool. Okay, so the next topic is evolution of programming languages. So that evolution of how the programming language is evaluated, like your history of a computer. So evaluation of computer, like that here we have a evaluation of a programming language. So here in that first here we have also five generations. Okay, in first generation programming language, So we that is a machine level language, and no translator was used to compile or assembly first generation, because so we are representing that one in machine code. What we have to convert? Okay, so that's why we don't have any compiler or a assembler in the first generation. Okay, in second generation program, we are having a assembly level language. Okay, that is codes, add, mul, those things we will have a second generation. In third generation, we will have C, C++, Java, Python, Perl, C hash, Basic, Pascal, Fortran. So all those things, whatever we are using higher level language, those things are comes under third generation programming language. Okay, so next fourth generation programming language, what we have: SQL, Oracle reports. Okay, so Unix shells, PLSQL. Okay, all those will come under that database management program and reportings. Okay, mathematical optimization, GUI, web development, all those comes under fourth generation. Okay, so here in fifth generation programming language, they are based on problem solving constraints given to the program. Okay, so here in previous all this we are using algorithms. So here this in this fifth generation is a programming language based on problem solving using constraints given to the programmer. Okay, problem solving constraints given to the programmer. So we are not using algorithms. Rather than using algorithm, that should be written by a programmer. That is the Prolog, OPES5, Mercury. Those are all different programming. So they are not using algorithms. Instead, these programming language, they provide the constraint, problem solving constraints to the programmer only. Okay, so we are not using any algorithms. Okay, so this is the fifth generation language. These are the evolution of a programming language. And last part of this, application of compiler technology, where we will use this compiler technologies. Why we are they have given kept this as a one subject, because this is very important for a computer science students. So what are the applications of this compiler technology? So first application is implementation of high level programming language. So without compiler, so if we are writing code in object program or assembly language, it's very difficult. Okay, so then we won't get, it should be very difficult, and it will be a very the program for programmer, it will be very difficult to write in assembly level language or a machine level language. So here when you want a higher level language, this compiler surely it will be there, because it converts from higher level language to lower level language. That's why there is implementation of high level programming language. That is very important. A high level programming language defines a programming abstractions. Okay, the program express an algorithm using the language, and compiler must translate that program to the target language. Okay, so that compiler must translate that program to target language. Okay, that is because we may use a number of algorithms. Okay, so those things will be converted into target language using compiler. So here when you have a higher level language, so it means we will have a compiler. Okay, second one is optimization for computer architectures. Okay, to optimize the computer architectures, we need this compilers. So in this first one is parallelism. What do you mean by parallelism? Okay, parallelism can be found at several levels. Okay, at the instruction levels, where multiple operations are executed simultaneously, and at the processor level, where different threads of the same application are different processors. So it means, so here when you have a parallelism, that is very for computer architecture. So to speed up the process, so parallel we will execute n number of threads or processes. Okay, so at that time we will have this technology. Okay, and memory hierarchies. Okay, memory hierarchies are response to the basic limitations that we can build very fast storage or very large storage, but not storage that is both fast and large. Okay, so here we add what happens, we can build a very fast storage or very large storage, but not storage that is both fast and large. Okay, what happens if fast and very large means, so if you want to search in that memory from a large memory, it may take time. So for compiler, it may we should build a fast and small memory, easily we can catch, because we need to convert a lot of things to lower level language. Okay, so then third one is design of new computer architectures. So when you want to design a new computer architecture, this compiler is very compiler tool will be technology will be used. See here in earlier days, what they are doing, the computer architectures design compiler were developed after the machine were built. Okay, once they build computer architecture, then compilers were developed. But in modern computers, compilers are developed in processor design stage. See here, that is very important. Nowadays, these compilers are developed in the processor design stage and compile code running. So before designing a new computer architecture, that is before designing a computer architecture, when even at the time of designing a computer architecture, this compilers are developed in process design stage only. Okay, when processor are designed, at that time only this compiler design stage will be will be developed, and it will be compiled code and running on simulators, is used to evaluate the proposed architectural features. See here. So in earlier days, after designing of architecture, they are developing a compiler. But when the processor are developing, designing, at that time only this compiler concept will be implemented. Okay. So then there is a fast processing and a lot of useful are there at that time designing. And last one is a compilation technology involves translator program translations. Okay, so when you are translating from higher level language to lower level language, this compiler technology will be used. Okay, the compilation technology involves the translation from higher level language to machine level. The following some of the program translators are techniques. So program maybe from higher level language to lower level language. So these are the some translator technologies are there. Okay, so what are those? Binary translators translation. So what is binary translation? That is compiler used to do binary translation to run on the other machines. Okay, so it may be binary transfer from, it may be converted from to zeros and ones. So at that time we will use this binary translation. And hardware synthesis, I think you are using HDL such as VLE, Verilog, these things in you are using in EC. Okay, so these things etc are translated into gates and physical layouts. Okay, so that when you are using that AND gate, OR gate, at that time we will use this Verilog programming. Okay, at that time this technology will be used. And query interpreter, so here SQL interpreters compiles the queries given at the command prompt. So here insert one value or a display. So at that time whatever, so we will we SQL queries, we will using structured query language, we will write the queries. So here that interpreter compiles the queries and given at the command prompt. Okay, it will compile and it will given at the command prompt. Okay, so then last one is compiled simulation. Okay, so here a simulation is a technique to validate the design. Okay, so here in EC in EC lab you are designing a circuits, so using that VHDL or Verilog. Okay, so here to validate the design, so whether that current you are using resistor, everything you are using. Okay, and you are simulating those things. Okay, so here at that time also we will use this compile simulation. So here VHDL are very lax and expensive than compilation to machine code. Okay, so these are the different applications we are using in compiler technology in different okay, so in the higher level, implementing a higher level language and optimization for computer architecture, in that we'll have parallelism, memory hierarchy, and design of new computer architecture and program translations. Okay, so in that we have binary and hardware synthesis, query interpreter, and combined simulation. Okay, today we